This section is about reference angles, and it's really about freeing our angles from the prison of being in right triangles. When our angles are stuck in a right triangle, they can only be acute angles. And so it gets harder to talk about things like what is sine or cosine of 130 degrees. So I'm going to show you how we deal with that problem. There's a word here, standard position. So standard position, I'm just going to do a little definition before we start. Standard position means that you have an angle that is set so that its initial side is on the positive x-axis. And for standard position, we normally go counterclockwise. So its terminal side will be somewhere else, but the angle would be from here to here because we want to go counterclockwise in standard position. So here's an example of an angle that is bigger than an acute angle, and we can figure out what the angle is. You might need to look at yesterday's notes, but what you do to do this is you start by drawing a reference triangle, and reference triangles are always going to be down to the x-axis. So you're going to drop from this point a triangle so that you're down to the x-axis. The reference angle will be this angle right here. We're interested in that angle. What I know about this right triangle is that this side is going to be 4, partly because I can just see that on the graph, and partly because that's the x-coordinate. 4 is a distance. I know the x-coordinate is negative, but the distance in that triangle would still be positive 4. And then the height of the triangle is going to be 4 root 3, because that's the y-coordinate. And those numbers look really familiar, and the reason they look familiar is because this is a special right triangle from yesterday's lesson. This is the special right triangle that you make with a 60-degree angle down here and a 30-degree angle up here. But the one you're interested in is the 60-degree angle because that's the one at the origin. So a couple of reminders. If I have a straight line, that straight line angle all the way from here to here would be 180 degrees, but the angle we're interested in is going to be 180 minus 60 degrees. So that means that this angle is going to be 120 degrees. So that's this angle right here. When we talk about angles that are in the plane instead of just in a triangle, we can also say, well, one thing I could do is just start at my initial side and go to my terminal side and end. And the other thing I could do is I could spin around 360 degrees and then go to my ending side. And if I do that, then I would say, or I could go to my side and then go another 360 degrees. So I could do 120 plus 360, and that would still be the same angle. I just spun around in a circle and still landed at that same place. So this is an angle that's bigger than 360 that describes the same angle. And then the other thing I could do is I could go backwards around the unit circle. I could go negative and still land in the same place, and so still describe the same angle. And if I go negative, I could do 120 minus 360 to get my angle measurement. So that would be negative 240. So there are lots of ways I can describe that angle. I can describe it by spinning around in a circle a bunch of times, or I could describe it negatively as well. These are two more, so I'm asking you to describe these two angles in 3 ways. 1, I just want the angle. 2, and then the other way I want to describe it is I would like to describe it as a number bigger than 360. And then the other way I want to describe it is a negative angle. So for part A, because it's all the way to this flat line, I would describe that as 180 degrees. So that's the first way I would describe it. If I want to describe it as in a way bigger than 360, I would do 180 plus 360. That means that I go all the way here and then I take another lap, and that would be 540. And then the third way I could describe it is I could take 360, I could take 180 minus 360, which means I go to that angle and then I go backwards around the circle. So that would be 180 minus 360, and that would give me negative 180. So now I have three different ways of describing that angle. I'll leave the other one for you to try, but you're always doing the angle itself, the angle bigger than 360, and the negative angle for this problem. When we're describing angles like this, where you want to find a reference angle, and we've already kind of talked about that, but the reference angle is the angle in the right triangle that we drop down. We make sure we're always drawing our right triangle to the x-axis, and this angle at the origin is our reference angle. So for this 130-degree angle, the reference angle is going to be 180 minus 130. Oops, I don't know why I wrote 135. Minus 130, which would be a 50-degree reference angle. And the reason we care about that is because this particular angle, 130-degree angle, is going to behave a lot like a 50-degree angle. The sine and cosine values of 130 are very similar to the sine and cosine values of 50. If you check that on your own calculator, make sure you're in degrees, but check and see what is sine of 50, what is cosine of 50, and what is sine of 130 and cosine of 130. I'm not going to go through it right now because you're capable of grabbing a calculator, but do that and notice what you see about those numbers. They should be very similar. Another type of problem is I could tell you the reference angle, and then I could ask you for the angle measurements for it. So if the reference angle is 10 degrees, I can draw a picture and say, here's my thing, and it's in quadrant 3. So if I count out, this would be 1, 2, 3, and this would be 4. So that's how we label our quadrants. I always remember it as it's also counterclockwise, just like when we do the unit circle, or just like when we do a reference angle. So I am saying I have a terminal side of my angle here, and then it's in quadrant 3, but the reference angle is 10 degrees. So it looks like this, because the angle is up to the x-axis. And if I want to figure out what the measures are, I would do 180 plus 10 degrees, and that would be the measure of that angle. And if I wanted to do the negative one, I would do 190 minus 360 would be one way to get to that answer. Or I could also do 180 minus 10, and that would give me 170. This would give me negative 170, but I know I'm going backwards. So this measure would be negative 170 degrees. So that's two different measures for that angle. Okay, I guess I drew it already. Here are two of them for you to try, finding the reference angle and figuring out what the angle measurement is. So the reference angle for, actually, I'm going to have you try these ones, and then after you've tried them, you can come back and return to the video. Pause now. So for the first one, the reference angle is the angle that it makes as you draw your right triangle up to the x-axis. It's the angle that's close to the origin. So in this case, it would be 210 minus 180. This would be a 30-degree reference angle. Again, that means that this angle, 210, behaves a lot like 30 if we do sine and cosine for it. And then the second one asked us to draw an angle that has a reference angle in the fourth quadrant of 45. And so that means that one measure of that angle would be 115 degrees if I go forwards, and the other measure would be negative 45 degrees if I go backwards. Okay, that's the first part of this lesson about the unit circle.